Hey, so today's the first day I'm actually doing a little bit of coding in Python on my own, testing out some things. My approach is to learn the fundamentals, like first principles. I want to be sure about the syntax, like when I'm working with a language. So basically just started off with the official Python tutorial on their website and started off on a tangent of Googling various things and looking at the documentation for various like facets of the language and how it works. So I just figured I'd make this video along the way just to jot down and share some of the things I learned. So first of all, we'll just pretty much go through the notes I made and talk about it, do some quick examples. So first of all, Python uses indenting to track grouping, not brackets. So just have this video.py file over here. So I just have this quick for statement. So I have a word, square, and for each letter in the word, I'm going to print the letter, and I'm going to print that letter concatenated with itself. And then after that loop is done, I'm just going to print the word once more. So if we run this, whoops, let me just broaden this window here. I'll just clear the terminal, use a clear command. That's another thing I just learned. If we run this, we see the letter SS, S, SS, Q, 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 etc. And then at the end it prints square once again. So because square was only printed once and it wasn't printed every time there was one of these other printouts, we know that it was not inside the for loop, and that goes to show that tabbing is how you organize your for loop. So if I wanted to have something that was, let's say for some reason I wanted to have my print function over here, then I could just move this for loop over to the right and move these two over to the right, and now my print is no longer inside of my for, and it has its own tab. So if I run this again, we see, oh, it says unexpected indent. Maybe that's because this is over here. Let me try this again. I'm learning as I go, so let's see what happens. So that ran. So I guess it didn't actually allow me, based on the linter, it didn't allow me to actually it's still giving me that same error. So if I'm understanding correctly, basically in Python it seems like you can't, or if you're using this linter with these rules, you cannot tab something out unless it really is starting like a new kind of some sort of loop or some sort of other structure where you would expect a tab. So that's interesting. So another thing, just learned, like first day with the language, comments are used with the hash sign, and to enter a comment for multiple lines, you can use control slash. Just some quick things. Division always returns a floating point number. So just jumping into the command console here, if I do 10 divided by 2, those are two integers, but when I evaluate it, it gives 5.0. It's floating point. Another thing is just the notion of using the command console, like for running these tiny little bits of code as I'm just learning the language. Super handy to just drop it into this command console instead of running the Visual Studio Code module every time. So another thing is the floor division operator. So if I do 13 divided by 2, 6.5. But if I do 13 slash, this kind of double division divided by 2, it rounded down to 6. So that's an operator I hadn't seen before. Python uses the Modulus Operator, which you might be familiar with. So I was already familiar with this. So it's like 13 divided by 2 once again with the Modulus Operator, 13 mod 2. And that's just going to give 1 because the remainder, when you divide 13 by 2, the remainder is 1 because it's an odd number. So classic use case for the Modulus Operator right there. Exponent operator in Python is 2, so it's something I've never used before. If I do 2 to the power of 4, 16, so double asterisk is the exponent operator. Equals is the assignment operator, which we obviously saw right here, just really basic assignment. In command line, last computed value or output is assigned to the underscore variable, so that's useful. Like right here, if I just hit print underscore, it's going to print 16, and that can be either a string or a number. So for example, I could do print let me just write here string as my string. And now I can hit underscore, and that comes back again. And I actually haven't tested whether or not this works in the command, this kind of window over here. So if I go print underscore, we'll see what happens. So I would expect it to be square. And I'll comment out the for loop so we don't have to see that this time. Oh, I don't want to comment out, do not want to comment out the assignment, or else nothing would happen. So it says there, underscore is not defined. So it looks like this actually doesn't work in the Visual Studio Code, but it works in the console. Alright, so I'll take that one out, and I'll uncomment these again. So, Python has built-in support for imaginary numbers, good stuff. Strings can be entered with either single or double quotes. And to enter a quote within a string, use the backslash sign before the quote. So we can see that over here. If I write the word bananas, gives me this one works because I've used different quote signs, different types of quotes within each other. So if I had done this single quote banana, then that doesn't work because I'm using the same single quote for both the indicating the barrier of the string and indicating where the apostrophe is in the string. So for this reason, it's best typically to use double quotes, so I understand. But this could be solved by doing the following, as it said there in the notes. If you do backslash apostrophe, that will not be read as a end of string, it will be read as an apostrophe. So you might need this even when you're using double quotes, which might be recommended when you're using a quote. So for example, she said, no way. Now I have this double quote scenario, and it's all broken. So if I go over here, add a backslash, and add another one over here, this prints out she said no way all as a string. So that's how that works. Let me see here, triple quotes. Triple quotes can be used to enter a string spanning multiple lines, so that lets you include the line break. So if I go here, if I do she said no, and let me just go over here and add triple quotes. She said no way. And now I hit enter, but the statement is not done. Computer knows it's not done, so now there's that ellipses, triple dot, showing that more code needs to be waited on to run this line. And so now I'll just enter this continuation of the string. I'll put a space and I'll put a period and a space, and then I said yes way. And now I'll end that there, and because it's a multi-line command, it goes to the next line, and now I just hit enter again with a blank line. Oh, I'm expecting it to be over, but it looks like it's not over, so maybe the string's not closed. Oh, it's because it's I used three quotes to close this. So let me just do this. So you can see there's all those extra slash ends because I didn't close it properly. So let me try this again. Let me go. She said no way. I said yes way, and then triple quotes to end. And now we see the slash n shows the line break was included. And if we do this over here, let me just comment this out. Control print, and I'll just do print. This is a string, and let me add these double quotes over here with line breaks. And now if I run this, we see that the line breaks are printed out within the string. Yeah, so I'm just going over a bunch of string functions because kind of like my research path led me there, and I find that they're pretty commonly used for many different reasons, so it's really good to know these things. Plus operator glues strings together, concatenation. So if I go print, or if I just do string no plus and string plus or concatenate way, prints out no way. So if I wanted a space, I would just have to add it on one of these, no way. If That's concatenation. And interestingly, there's this star operator which repeats a string. So if I do, I can just pick a number, so like 3, and then star, and now I'll add a bracket around this entire string. So it's going to evaluate that first. And now I get no way, no way, no way. So if I just add a space to the end over here, I get no way, no way, no way. So that's a new operator I've never seen before. And because Python's a strongly typed language, strings and numbers can't be concatenated until the number is cast into a string type. Super important. So for example, if I had a string which was, let's say my string is 6, so apostrophe 6, that's a string. And if I try and do 6 in a string plus 1, it's an error, because the plus is addition for a number, but it's concatenation for a string. So to get a 7 for this, I would have to cast my 6 as an integer. So I do casting with the int function. So I cast 6, and then add 1 to that. Oops, 11. Now we get 17. And vice versa, if I wanted a string that said 61, if I had a 6, and I wanted to add to it a 1 to make 61, like let's say this was a phone number manipulation or a street address manipulation where you want to treat the number like a string as part of a sentence, then if I had, let's say 6 equals 6, 1 equals 1. Now we see if I try to do what I just did over there, 6 plus 1, it's an error because 6 is a string, 1 is an integer. What I'd have to do is I'd have to say 6 plus string casting, so 1. And now that's 61. Yeah, so substrings are indexed. This is a really interesting feature I thought of Python, where pretty much it seems to me, from what I've seen so far, everything's an object. So strings are an object, a collection of substrings which are just individual characters, and so these are indexed, and the first one has an index of 0. So let me just say that I have, a name. So name equals Kentucky. And then if I do name and hit that square bracket, so it's like indexing 0, I get the first letter K. Likewise, I do it again. Second letter, second index is index 1, E, etc. So there's the enumerate function. So if I do, actually I don't know if print. There's an enumerate function, but I'm not 100% sure on how it works. Let me try it. Print enumerate name. Don't think this is going to work. So it's an enumerate object. So I think I have to do print next enumerate object. Now we'll probably just talk about this in a couple minutes. So now I get K. If I do that again, it keeps coming up K. Interesting. So I think I know why that's happening because I was doing some more reading before, but just another thing about strings and indexing here, you could use what's called a slicer. So if I say name and then open that square bracket and now separate two numbers with a colon, so for example 0, 3, it's going to print out all the characters from the 0th index to the second index. So that's 0, index 0 is K, index 1 is E, index 2, third letter, N. So slicer notation like this is always going to include the first number, the index of the first number you write there, and exclude the, it's going to go up to but not including that final number you specify in the index. Yeah. So also if you go negative indices, you're going to get the letters in reverse. So starting with the last letter, so 0 is not, 0 is the first letter, negative 1 is the last letter, negative 2 is second last letter, etc. Yeah, so going on from there, we could say we got our slicer, some things about errors. So a new string cannot be assigned to a single index value. So if I wanted to say, right now I have Kentucky, right? If I just go name, I have Kentucky. If I wanted 1 Kentucky, or if I wanted, let's say, Kentucky, something like that, it doesn't work to do like name and then first letter, so index 0 equals C. as a string. That doesn't work. That's just all that this is referring to. And then a function you can use often is the length function. So len and then name. This will return the length of my string. So it has 8 letters. Kentucky has 8 letters. Okay, yeah, so for a for loop, I have some notes over here. Learn about how for loops work. I thought it was really interesting. So pretty much like we saw over here, I'll just jump back to this example. Comment that out. You pretty much start with for, and then you name a variable. This is going to be your iterator. So for every iteration through the for loop, you're going to have this variable being an element from a collection, which is called an iterable object. So you can only use a for loop on a iterable object, and what you're going to do is iterate through some sort of collection corresponding to that object. So in this case, the object is a word. So what we're iterating through is the letters. So I just called it letter, but you could call this whatever you wanted. It doesn't have to be letter. It could be whatever variable name. And then you're going to have your iterator name, and then in, and then the variable name corresponding to the iterable object you're iterating through, and then colon. If you don't put that colon, it's going to break. And then have tab and your functions that you want to do within your for loop. So this is different. What's notable is that this is different from other languages where you have a certain paradigm, such as you might have for, and then you'll have some sort of initialization, like I equals 0. And then you'll have something like your end condition. So for I equals 0, and you keep doing this while I is less than 5, and then you have some sort of, on your next iteration, type of condition. So you could increment it. So I equals I plus 1 type of thing. This is like what a bunch of other languages use. So you do I equals 0, iterate, I equals 1, iterate, I equals 2, etc. until you reach I equals 5 and then quit. So this Python is not like that at all. You just have, you use an iterator, and you iterate through a collection. So the nature of the collection is going to be different for different types. So here it's my word. So the type you're iterating through is the individual letters, but for a different data structure or object, the iteration, the iterator that you're using is going to be different. Another thing I thought I'd talk about is just functions. So we have lambda functions. So lambda function is, you're going to write that out as, you're going to call it out with lambda, and then you're going to have, I believe actually this is a colon right here. Let me leave it down. Yeah, so no, you're just going to have lambda, and then followed by arguments. So let's say x, comma, y, comma, z, and then a colon, and then the function. So then let's just say this is x multiplied by y plus z. Very simple, whatever. X times y plus z. And now this is how you define a lambda function. So a lambda function can be used in different ways. One way is that you could assign it. So I could say my function equals this function. And this means that then you can use my func as a function. So if I say print my function, and then I can add arguments here. So x, let's say, is 1. Let's just say x, y, z is 1, 2, 3. Now, this is going to do, before printing, it's going to evaluate the function. So it's going to do 1 times 2 plus 3. So I wasn't careful with my capitalization, and that gave me an error. So if I try this again, now we see that's 1 times 2 plus 3 equals 5. So we just use a lambda function. It actually changed lambda to define. So I just defined my function. So from my understanding, you can actually use a lambda function as, let's say, you could use it. It's used, from what I understand, as a way to define functions like sporadically for just immediate use. So for example, let me say I had x equals 1, y equals 2, x equals 3 over here, or z equals 3. Actually, that might not work. Let's just try it. Z equals 3. Then if I do print and then this lambda function, lambda x, y, z, colon x times y plus z. I actually don't know if this will work, so we can just check it out. So it didn't. It just says we printed out the fact that we have a function, but it didn't print out this function with these arguments put into it. But my understanding is that you can use a lambda function in different places. So for example, let me just bring up something over here. Oh, you could use it for assignment. So what you could do is, if I wanted to say, actually, I'm not sure what the limitations of it are. I'll just think, I think I just tried to do an assignment with it earlier, right? So my fun equals lambda x, y, z, x times y, z. Now, let's delete this. If I hit, yes, when I hit Control S, it automatically changed to define. So I think actually this doesn't need to be defined, but my linter is changing it to that. So in any case, and that, yeah, it's adding this return keyword, which isn't strictly necessary for the lambda function because it's like a one-liner. So anyways, I'll leave that discussion there. Obviously, still learning, but that's just the idea. Then when it comes to arguments, so we just seen here how you define a function. You use the define keyword def, and then function name, and then arguments. And what you can do is make arguments optional. Arguments are optional when they have a predefined value. So I can do this right here. I can set this value for z equal to 1 within the arguments, and then when I call this, print my fun, and then I'll just do 1 and 2. So now that z value, I haven't entered an argument, so it's going to be automatically defined as 1. So this output will be 1 times 2 plus z plus 1, so 3, and that's what we see over here. So that's how you can make an optional output that's not strictly necessary. If I didn't have z equals 1, if I just had z and I try to run this, it will break. So because I have a call on my function with not enough arguments, my fun is missing one required positional argument. So something to note there is that you cannot place an optional argument in front of the others. So I'll fix this. Now you'd think this would work. So if I run this, it says here non-default argument follows default argument. Yeah, so I have y and z, which are non-default, following a default argument. That doesn't work. So that pretty much sums up not much of a summary, kind of a long video. Just trying to go quickly through what I learned today. I was just doing a bunch of research, so looking forward to learning more and putting this stuff to use. Thanks for watching.